Now that we know what tolerances are, let's discuss why we use them. All dimensions must have a tolerance at some point in a manufacturing process. In fact, there are many benefits to having these tolerances. The first is to just communicate the manufacturing limits of your part. For example, we have this tolerance here placed on the width of this part. We would have a 0.5 total length tolerance, plus or minus 0.25, on this part that is 20 inches long. This clearly communicates what the target is, which is 20 inches, and where the outer limits would be, 19.75 and 20.25. It's important to have this information so that when the machinist makes this part and they go to inspect it, they know if it's acceptable or not. Next, tolerances help convey critical dimensions on our parts. Let's consider this pocketed feature right here. Without a tolerance, we have no idea how important this dimension is, especially since we don't know what the limits need to be. What is the manufacturing process that we have to use here? Can we drill it by hand? Does it need to be reamed? When is this hole too big or too small to not fit the application? Is our customer going to reject the part? Is our supplier going to use an extremely expensive method to produce this when maybe it's not that important? Well, now when we give it a tolerance, we can determine how important this feature is and how we need to manufacture it. Looking at this tolerance right here is an extremely tight tolerance. We can only go from 0.8742 to 0.8746. That's very hard to hold. In this case, it dictates that the part is probably going to cost us more to manufacture because we have to use some sort of specialty process. It also tells us, though, that this is functionally critical and may be used for something like a press fit. We now know this dimension is important and need to treat it as such in the manufacturing process. Tolerances, most importantly, ensure assembly with other parts or fit and function. For example, if we have this yellow and green part right here, without tolerances, there's a high probability these parts will not fit together if we can just make them however close to this 0.250 that we want it to be. We can make this yellow part just slightly too big and this green part just slightly too small, and now they won't fit together at all. Now, if you receive this part on your print, you may not have information on the other part. So you need to know what the manufacturing limits are to make sure that this part can be approved, and therefore when it gets sent into assembly, will assemble together properly. We can always ensure these parts fit together if they have proper tolerances. Now, we won't go into detail too much on why these will always fit together, but as you can see on the yellow part, it can't ever get larger than 0.250. That is the upper limit. And for this green part, the hole can never get smaller than 0.251. That means that no matter what, these two parts will always be able to fit together if the proper tolerances are met. It is the responsibility of design to make sure that these two parts will go together, but it's information that they are conveying to the person reading the drawing to make sure they make the part correctly so that later on in the assembly process, they don't have a major issue. Finally, from a legal standpoint, tolerances define the acceptance criteria for part inspection. Remember, these drawings are contracts, and in many cases exist between two different companies. If a company cannot properly meet the tolerances, they are not able to fulfill the order that has been provided with the drawing. So these tolerances determine the difference between accepting, and thus paying for the parts, and rejecting the parts completely.